Hello everyone, welcome back to Science Simply, where complex doesn't have to mean complicated. Last video, we left Priya mid-problem. She drove 8 kilometers east, then 6 kilometers north, and we established that her displacement wasn't 14 kilometers, even though that's what you get if you just add the numbers. The real answer was 10 kilometers, at an angle northeast. We used Pythagoras to get there, but we didn't explain why that works or what to do when the vectors aren't conveniently perpendicular. That's what this video is for. By the end, you'll be able to add any two vectors using two different methods. Find the resultant vector and split any vector into its components. Let's pick up where we left off. Just to ground us, a vector has two things, a magnitude and a direction. Displacement, velocity, force, all vectors. A scalar like temperature or mass, just a number. There's no direction. The reason Priya's 8 kilometers east plus 6 kilometers north didn't equal 14 kilometers is that vectors don't add like scalars. Direction changes everything. What we need is a systematic method for adding them, and there are two. The first method is the triangular law of vector addition. The rule is this: to add two vectors a and b, place the tail of b at the head of a. The resultant vector r goes from the tail of a to the head of b. It closes the triangle. So as you can see, like, let me give another example. Let's say we have a vector like this, p. This is a p vector, right? And let's say this is a q vector. I must write q. So if I write the vector symbol, so it means, right? So basically all we have to do is to add p plus q, the actual vector completes the triangle. So it looks something like this. So this is p plus q. Alright, so let's use Priya's exact journey. She drives 8 kilometers east, then 6 kilometers north. What's her displacement? So first let's just draw the vectors. So this is 8 kilometers east, so it's 8 kilometers, and then this is 6 kilometers north, so goes like this, 6 kilometers, right? And since they're joined from head to tail, we can uh, complete the triangle, and this will be her displacement. Now there is a formula to calculate this, but you don't need to apply the formula if you don't need to. So you can just you know that north and east are perpendicular, so just use Pythagoras theorem. So basically, to apply Pythagoras theorem, we can do something like this. We know it's a right angle triangle, so the magnitude of s is basically 6 square plus 8 square, all of that under the root, and all of this is in kilometers, obviously, because it keep the unit, because you know vectors have a unit as well. So this will be what, 10 kilometers, right? And to find the direction, we have to use trigonometry. So as you can see, if we take theta as this, as it's with the horizontal, you can take tan theta. This is equal to 6 kilometers, because remember, SOHCAHTOA, opposite by adjacent. 6 kilometers by 8 kilometers. Kilometers cancel out, and you have to take you get theta. You have to take the tan inverse on both sides. So tan inverse of, what is this? This is 0.75. That will give you approximately this value, 36.9 degrees. Alright, in math you usually get answers in radians because it's easy for the unit circle, but for physics you usually take it as degrees, unless you're doing a circular motion, but we'll come to that much later in the course. Alright, now the second method, and this one is useful when two vectors act from the same point simultaneously. Think two forces both acting on the same bolt at the same time. So Priya's journey was sequential, one leg after the other. But let's say if two forces act on an object together, they share the same starting point. And that's when you use the parallelogram law. The rule: place both vectors, tail to tail. draw the parallelogram. The diagonal from that shared tail is your resultant. The formula, and this one you need to memorize, the magnitude of r is the root of a squared plus b squared plus 2ab cosine of theta, where a and b are the vectors and the theta is basically the angle between a and b. So here's some special cases you need to know. If theta is 0, the resultant is maximum. If theta is 180, the result is minimum. And if theta is 90, the 2ab cosine theta gets cancelled out. But why does this happen? Well, to do that, we need to know about the cosine values of these angles. So cosine of 0 degrees, is equal to 1. So if you substitute 1 in this, you just get a squared plus 2ab and the cosine theta comes out. Right? Simple enough. Now, let's take the other example. The cosine of 180 degrees. That's equal to minus 1. Now, how does that make this value minimum? Well, if you substitute minus 1 into this plus sign becomes a minus. So you get minus 2ab. And note that it's the minimum possible. Alright? Now, what about this special case? Theta equals 90. Well, cosine of 90 degrees is equal to 0. So if you substitute 0 into this entire term gets cancelled out. So you just get a squared plus b squared plus 0. And that's where you get a squared plus b squared. Now, how you get the cosine values of these angles is a whole nother video, and that's related more of a math side thing. So if you want to explore that, that's a job you have to do on your own. But if you want to continue with this course, just know that these values are good enough. So why should I just blindly follow the formula? There must be a reason how someone could have found out this specific formula, right? So let's prove it together. So we have vectors A, vectors B. They both start from the same point, so we can say that these two are the vectors. I'm going to draw an arrow for symbolism. And let's do a setup, right? So OQ, so this part, O to Q is vector A. O to P is vector B. Angle QOP is theta, which is the angle between A and B. And let's draw a perpendicular. So SR is perpendicular to OQ, right? Because the angle here is 90 degrees. So in SQR, this triangle, right? First principle to note is that theta here is the same. Why? Because they're corresponding angles. These lines are parallel, right? It's a parallelogram. So if you draw a tangential, look at this, the same angle. So we can derive that QR is B cosine of theta. How we got this, that's what we're going to discuss next, but just take it as face value for now. And this is B sine theta, right? So as you can see, O to R is A plus B cos theta, right? Because this is length of A, this is B cos theta. So if O to R, this takes the sum of both of these. So now we have a right angle triangle that it's difficult to visualize, but its R is a hypotenuse, A plus B cosine theta as the adjacent side to theta, and also B sine theta as the height of the triangle. So if you solve using Pythagoras theorem, you'll get something like this. Right? If you take b squared common from this term, you're going to get cos squared theta plus sine squared theta. Now, to prove this formula is a whole nother video, but just know that sine square of a angle plus the cosine square of the same angle is always 1. And that's why this term just becomes, this cancels out, and you get a square plus b square plus 2ab cos theta. Right? Simple. And if you write the root on both sides, look at the root of that. Simple. So let's use that in a question. So two forces, 5 newtons and 7 newtons at an angle of 60 degrees between them. Okay, so as you can see, what's gonna happen is there's two forces. I'm just gonna draw 7 newtons, and then this is 5 newtons. not on a scale, but just note that, it's 5 units. And then we just draw the parallelogram. I know we have to find this. Now, what's the formula for this? I'm just going to draw the symbol F net, which stands for net force. What net force is, don't worry, we'll get into that in a future video. But for now, just take it as face value. So F net, or the magnitude of it, is equal to square root of 5 square plus b square, so 7 square, plus 2 into 5 into 7 into cosine 60 degrees, right? So this is just 25 plus 49, and then cosine of 60 is 1 over 2, so you can say that 2 into 5 is what, 10, and 10 into 7 is 70, and 70 over 2. So now you get 25, 49, and 35. This becomes 19, and this becomes 6 plus 10. So 109, root of 109. And obviously it's in newtons because the unit of force is in newtons. So it's always in newtons. So it's a root 109 newtons. It's pretty easy, right? So if you take it like this, and if you want to simplify the 3 significant figures, which we discussed in the first video, if you remember, that's 10.4 newtons. Alright? Now let's find the proof of another property, which is the angle between the resultant and the horizontal. So just to define, this is alpha, and we actually have to find alpha, we have to do the tangent. Alright? But tangent of what exactly? So we already have established this diagram, so I can say this is b sine theta. How this comes, again, we'll come to in a minute. B cosine theta. And if we take this right triangle, we'll find that tan alpha is the opposite over the adjacent, right? So cotota. So tan alpha, if we substitute SR into here and OR into here, we'll get this, right? So basically, tan alpha is b sine theta over a plus b cosine theta. So to take tan inverse on both sides, alpha becomes the tan inverse of b sine theta over a plus b cosine theta, right? But special case here, tan alpha equals b by a, or alpha equals tan inverse of b by a. How is this actually possible? Well, for that we have to set theta to 90 degrees, alright, because they're perpendicular. So if you do this, right, if you do this, so alpha basically equals tan inverse of, first, b sine 90 degrees over a plus b cosine 90 degrees when theta equals 90. Right? So how do we simplify this? Well, sine 90 degrees equals 1, and then sine and cosine of 90 degrees equals 0. Right? So substituting that, sine 90 here just becomes, let me just put tan inverse first, right? Sine 90, 1, just take b. Then you get a cosine 90 is 0, multiply that you get 0, so b by a. And that's how you get this formula. Right? Pretty simple. But just in general, alpha is equal to tan inverse of b sine theta by a plus b cosine theta. Right? Easy. Now, we have been using this word resultant vector for so long, right? But what does it actually mean? So the resultant vector is a single vector that has the exact same effect as all the original vectors combined. So for Priya, the result was a straight line arrow from the warehouse to the customer's house, 10 kilometers at 36.9 degrees north of east. One vector. Same effect as the two north legs and east legs combined. So the key insight, if you have more than two vectors to add, chain the triangle law head to tail, head to tail, head to tail, and the result is always a vector that closes the shape from start to finish. So for the direction, when using the parallelogram law, tan of theta, as you already said, where alpha is the angle that the resultant makes it vector A. Now, there's one step that we mentioned on the slide, is resolve, right? Resolve the components and then add. What does resolve actually mean? And this is what it means. So for any vector um, at angle theta above the horizontal, it splits into two vertical parts. Remember how we added it before? This time we're dividing the vector. We're making it into smaller parts, or splitting it in one sense. Okay? So why do we do this? Because perpendicular components don't affect each other. And this is exactly what we did with Priya in reverse. Her resultant was 10 kilometers at 36.9 degrees northeast. The two components were 8 kilometers east and 6 kilometers north. Resolution is to balance that process backwards. Alright, so the horizontal component, which is represented by Vx if the vector is V, is V cosine theta. Vy is V sine theta. Now, how did we get use this in this proof? But how do you actually derive this formula? Well, let's just take the sine and cosine of theta. So sine theta is equal to Vy over V. So you get Vy equals V times sine of theta if you transpose on the other side. Same way, if you get cosine theta adjacent by hypotenuse, Vx over V. So take Vx on the left hand side, transpose this on the other side, you get V times cosine theta. Very complicated looking formula, but it's very simple to derive and use. Alright, so let's use an example, right? So we have to resolve a velocity. A ball is kicked 20 meters per second at 30 degrees above the horizontal, right? So we have to find the components. Well, we know that this is 30 degrees, and if you take the cosine formula and the sine formula, you get this is 70.3, this is 10, right? How? Well, Vx equals 20, cosine of theta is root 3 by 2. So you basically get 10 root 3 as Vx. Alright. Now Vy is 20 sine of theta. So Vy is 20 into 1 over 2, which is 10. And obviously meters per second on both sides, because you know velocity is a physical quantity and it's a unit. Alright, so 30 degrees, opposite, adjacent, hypotenuse. We filled out all of the possible resolutions of the vector. Alright, now let's talk unit vectors. Unit vectors have the magnitude exactly 1 and point in a specific direction. So they're just directional labels. This is the way you're going to see direction being represented. Okay, so in physics you usually have three standard unit vectors. I is a unit vector in the x direction. So for example, if you have a vector that's 2 I cap, it's 2 units on the x-axis. Next, j cap, which is a unit vector in the y direction. So for example, if you have a vector like, let's say 5 j cap. That's basically just 5 units on the y-axis. And k cap, well, that's a very complicated unit vector that's dealing with 3 dimensions, and that's basically in or out. I can't really represent it on this 2-dimensional plane, obviously, but just know that it's forward or backward. That's basically what you can translate k cap as, right? So any vector can first be written as vx I cap plus vy j cap. Now this makes sense, right? Because first you're calculating the the quantity by how much they're moving and in the I cap direction. Same way, the vy is just calculating how much you're moving in the j cap direction. So this is just standard, but you can also say that to find the unit vector of any vector, you divide the vector by its magnitude. Okay? So let's try and find the direction of Priya's displacement. So it's gonna be the vector first, which is 8 I cap plus 6 j cap, right? And its magnitude, that's just 10. So this is basically going to be 0.8 I cap plus 6 j cap, 0.6 j cap. So what you're going to see is it's on the graph 0.8 I cap plus 0.6 j cap. This unit vector has always have a magnitude of 1, but notice the direction is just the direction of Priya's displacement, and that's why unit vectors are useful. And if you want to find out the formula of any vector, like let's say A, is just equal to its magnitude times the direction, which is the unit vector, and that's how we get this insane formula. The looks complicated, but it's just very simple. Alright, so here are some key takeaways. Triangle law, head to tail, the resultant closes the triangle, and this is what solved Priya's 8 plus 6 kilometer journey. The parallelogram law, tail to tail, so this resultant is the diagonal. R is equal to the square root of a squared plus b squared plus 2ab cosine of theta, used when the vector acts simultaneously from the same point, such as when you're dealing with free body diagrams. We'll get to those in a moment. Next, we learn the resolution of vectors. Split any vector into v cosine of theta, the horizontal one, and v sine theta is the vertical one. So Priya's 10-kilometer resultant decomposes back into 8 I cap plus 6 j cap kilometers. Speaking of I cap and j cap, we discussed unit vectors. I cap, j cap, and k cap. They only carry direction, and you can write any vector as vx I cap plus vy j cap. Alright, so Priya's done a lot of work across the 2 videos. She's earned a rest, but you still have something to do. If this clicked for you, drop a comment. Which of these trips you up the most? The parallelogram formula, or figuring out which component uses sine and which uses cos? I read every comment. Alright, so hit subscribe for the next of the mechanics series. Next up, well, you're gonna be after watching this the night before an exam. Good luck, you've got this.